Hi guys, this is Biswajit Tripathi, and this video is all about how to improve a materialized view performance while doing a complete refresh in Oracle. Okay, so before we discuss this in much detail, we'll first know what is a materialized view. So I hope you know about what is a table and view in Oracle. So you can think of materialized view as a view of a master table that has actual data. Okay. So in general, view doesn't contain any data. Whenever you query a view, it actually queries the master table and fetch the data. Okay. But in Materialized view, it stores the local copies of read-only data. Okay. And uh, it reads the remotely located data in remote tables, which you can say it as snapshots. Okay. So and this materialized view can be refreshed based on the refreshing options, and there are several materialized view refresh options available in Oracle, such as complete refresh, fast refresh, and force refresh method. Okay. And these materialized views are created with primary key or row id or subquery. Okay. And materialized view can be a read only view or updatable or rewritable. Okay. So in case of read only view, materialized views, you can only read the data, but you cannot write or update the data in materialized view. Okay. And in updatable materialized view, you can update the data in materialized view, and while you do the refresh of that particular MB, then the data inside that those materialized view will be pushed back into the master table. But in writable MBs, uh, you can update the data, but on while doing the refresh, the data will not push back into the master table. It will be lost on refresh. Okay. So and updatable views can be part of some it should be a part of a materialized view group, but writable MBs will not be a part of any materialized view group. So maybe in next video or upcoming videos we'll see how to create a materialized view group, or and how to assign a materialized view under that particular group. Okay. So now we'll see what are the refresh methods, and how to refresh a materialized view, and how we can improve the performance. Okay. So in complete refresh, what it does, it executes a materialized views defining query. It essentially recreates the materialized view, but and also it takes more time than the fast refresh method. Okay. But sometimes fast refresh method is not always we cannot do always fast refresh method because there are some constraints. So okay. And when you are refreshing materialized view with complete refresh, then the total result set of the query will replace the existing materialized view data. Okay. And if you are performing a complete refresh on master MB, then you will have to perform complete refresh in the following MBs, or else it will not work. It will throw an ORA error. Okay. So, and what about the fast refresh method? So it first identifies the changes that occurred in the master table. Okay. And since the most recent refresh of the materialized view, and then apply the changes in the materialized view. And this fast refresh method look the materialized view log, and what are the data changes since most recent refresh of materialized view, and apply the changes. And it can it refreshes only when the master table has a materialized view log, or else it cannot. And to make fast refresh to be more faster, so each join column in the materialized view statement must have an index on it. Okay. Then coming to force refresh method, uh, so it will do a fast refresh. Okay. If fast refresh is not possible, then it will do a complete refresh. So anyhow it will refresh the materialized view, so that's why it name as force refresh method. Okay. And this materialized view can be refreshed in scheduling interval. So depend on your requirement, you can decide that schedule or what should be your scheduling time interval. Okay. And so I'll just demonstrate while how you can improve the performance of a materialized view while doing complete refresh. Okay, so now I'm going to as you can see, I'm going to create a table, okay, of columns less than 10,000 10,000. Okay, so I'll run this. So table is now created. I'll see what is the count in that table. So it should be 9,999. Okay, so now I'll create a materialized view of for that particular table. Okay, and see, I'm mentioning here refresh complete. That means it will do a complete refresh. And when it will start with the C state. Whenever I create the materialized view, then it will refresh, do a complete refresh on the table. Okay, and the next schedule interval will be a 1 day after that. Okay, and it is doing the query is select column 1 from table 1. Okay, so now I'm creating the materialized view. Okay, so now materialized view is also created. So what happens when performing the complete refresh? By default it uses delete plus insert operation. Okay, it means it deletes the rows from materialized view one by one and then insert new rows into it. Okay, so and it happens in a single transactions without any user interface. Okay, as you know, every DML like insert or delete, it generates high redo logs, and which in results it also takes time. Okay, but what we can do, instead of deleting rows one by one, we can truncate the whole table and then insert the new data. So that can be also possible. So we can use the truncate DDL plus parallel DML mechanism as well. Okay, so and also we can do that by just setting a parameter which is atomic underscore refresh. Okay, and by default in Oracle it is true. Okay, so now I'll see if matter what is the count in the materialized view now. So it should be 9,999. Okay, so to compare the performance with between insert plus delete operation with and truncate plus parallel DML operation, I have just written one small script so that you can just to demonstrate how the performance it is there. Okay, so what I'm doing, I'll do a complete refresh with setting this parameter atomic refresh to true, and by default it is true. Okay, so maybe while testing it, I might have updated to false, so that's why I'm just mentioning it. Okay, okay, so first I'm doing a refresh of that materialized view with complete refresh and setting the atomic refresh parameter to true. Okay, and we'll see the timing. Then I'll refresh the materialized view with setting the parameter atomic refresh to false. Okay, so now I'll execute this script and we'll see the timing. Okay, okay, now it is executing. Okay, so it has been executed and you can see the total time taken for complete refresh with delete plus insert operation, which is by default by setting atomic refresh to true. So see, it took 4.41 seconds because the output of this dbms utility get time, it is in hundreds of seconds. So the actual time is 4.41 seconds, while by setting parameter to false, see the time taken is 1.1 second. So for only 10,000 rows, you can see the difference in 3 seconds. So if we would have create the table with 1 lakh or 1 million rows, then the performance impact would be high. So so this is how you can improve the performance of materialized view with while doing complete refresh. So that's it. So thank you guys, and please like, comment and share this video, and don't forget to subscribe this video. Okay, um, thanks for watching.